Welcome back to Dave Does Math from Home. We are starting a part 2 for our section on factoring polynomials. Part 1 talked about the reverse FOIL technique that works when you have something like x squared plus ax plus b. When you have something where the coefficient here is a nice, simple, positive 1. This is usually called the trivial coefficient because it's nice, it's easy, it makes sense. When you have a nice, trivial, simple, positive 1 here, then we know how to factor this. We just need to find two numbers that multiply to get you b and two numbers that add to get you a, and then you're all set and you're done. This video is going to be about what happens, first of all, when you have 4 pieces of your polynomial instead of just 3. And then we're going to talk about what happens when you have a quadratic with a non-trivial coefficient. We're going to start with the 4-term pieces. So when you have something like, we'll start with x cubed minus 4x squared minus 9x plus 36. We'll start with something like this. Sometimes 4-term polynomials are very, very easy to factor. A lot of times they're almost impossible to factor. We're going to talk about what to do with the easy ones. If this easy technique doesn't work, we're going to give up. The process for factoring things that this easy technique doesn't work for is exhausting and would take like a couple days to teach. It's a mess. So we're not going to deal with it. We're going to let computers do that for us. But if we can factor these things easily, we're going to factor them easily. The trick to factoring these things easily, if they factor easily, is to cut them in half. And pretend that half of it doesn't exist. So if we pretend that this half doesn't exist, and we're only looking at these pieces, and we want to factor something out of these pieces, the thing that these pieces have in common is an x squared. And what's left from just this first part is an x minus 4. And then if we pretend that this half doesn't exist and we want to factor these, the thing that these guys have in common, I'm going to say, is negative 9. If we factor a negative 9 out of this, then this will be an x here, and this will be a minus 4 here. I could have factored out just a regular 9, and then this would have been a negative x plus 4. But it's very important to me to try and make these two things match. Because now that they match, I can pretend like this is just one whole giant piece A, and this is one whole giant piece B. And now it's like I have two pieces again. Here's piece A, here's piece B. It's just like I had here, piece A, piece B. I want to see what matches within these two pieces so that I can factor the matching bits out in front and leave the leftovers behind. The thing that matches between piece A and piece B is x minus 4. So that's what I'm going to factor out in front. If I factor this x minus 4 whole piece out in front, what's left from piece A is x squared, and what's left from piece B is negative 9. And so now my factoring is x minus 4 times x squared minus 9. So, like I said, it's not too bad. When these things factor easy, they factor pretty easy. But we need to be very careful. Because for this particular problem, we're not quite finished. Sometimes in these problems, you'll get to this step and you'll be finished. Sometimes you'll have one more step to do. And it depends on what you get here. One thing that we didn't talk about in the last video is a factoring technique called difference of squares. When you have something like x squared x squared minus, I'll call it s squared. when you have something that looks like this, I'll separate the things here. Pretend for a moment that this is actually x squared plus 0s plus s squared. I'm sorry, minus. We're looking, if we try to factor this like we factored everything from part 1 of this video, we're looking for two numbers that add to give you 0 and multiply to give you negative s squared. And that I think is always going to be x plus s and x minus s. If you add these things together, plus s and minus s will give you 0. Actually, this should be an x, shouldn't it? But here we go. Positive s and negative s should give you 0. Positive s times negative s should give you negative s squared. I use the letter s, s is for squared. So if you have something like x squared minus 16, that'll be an x plus 4 and an x minus 4. If you have something like x squared minus 81, that'll be an x squared plus 9, x plus 9 and x minus 9. This technique is called the difference of squares, because this is squared and this is a square, and you're subtracting them. So it's like subtraction between square pieces. And that's what we have right here. So we're going to factor it one more time. The x minus 4 will hang out. This will be an x plus 3, and this will be an x minus 3. And that is now completely factored. Sorry that this probably feels a little disjointed. I should have talked about the difference of squares first. I did not plan this very well. Sorry about that. But we got there in the end. I want to do one more example of these things. And then we're going to talk about what to do with a quadratic with a non-trivial leading coefficient. So let's do x cubed plus 7x squared minus let's do 8x minus 56. Okay. For these ones, and for anything that has 4 terms, whenever you have 4 terms, we're going to start by splitting it in half. 2 pieces. Chunk it right down the middle. Look at what the first 2 pieces have in common. Looks like it's an x squared. So this will give us an x plus 7. And in the back end, we're going to take out the negative 8 so that we have an x plus 7. The x plus 7's match, so I can pull that out as well. If you do this step and your pieces don't match, try to take out a negative here instead of a positive, or see if you can change what you took out of these 2 pieces to make them match. So we get an x plus 7 is the common piece that we're taking out of both of these, and what's left from this is just the x squared, and what's left from this is the negative 8. I guess we could, if we wanted to, we could say that this is x plus the square root of 8 and x minus the square root of 8, if you like. Or you could just leave it like this. I don't care which. If this is a nice round square number like 16 or 9 or 25, 36, if it's a nice even square, then I want you to split it into the 2 pieces. If it's a number that doesn't have a nice square root, then you can do it or not do it. I'm not fussed. If you get something like this, then you can't factor that. That's called prime. Prime means cannot be factored. So that's how to do 4-term polynomials. There's one thing left to discuss, and that is what to do when you have non-trivial leading coefficients. So that's what happens when you have something like 2x squared plus 7x plus 3. This particular problem is a little bit more difficult than what we started out with in part 1 of this video series when we were just doing the reverse FOIL technique. And it's because there's a 2 here, and that 2 here kind of screws up everything. So there is a way we can do this, and it's not terrible. It adds a couple extra steps, but none of the steps individually are really a challenge. It just takes a little while. I call this sort of the AC method. So if we think about sort of the standard issue quadratic, that's ax squared plus bx plus c. So we want to look at the a and c terms, and we want to multiply them together. In our case, a times c is 6, and b by itself is 7. Instead of trying to figure out two numbers that multiply to give you this and add to give you this, we're going to do that with these numbers. I want two numbers that multiply to give us 6 and that add to give us 7. That's the goal here. So we're doing the same thing. We're just using these numbers instead of these numbers. The two numbers that multiply to give us 6 and add to give us 7 should be 6 and 1. And here's where a lot of students make mistakes. Because when we're doing like a normal thing, like if we were doing x squared plus 7x plus 6, if we were factoring this, now that we found the numbers that multiply to give us 6 and add to give us 7, once you found them, you're finished, right? X plus 6, x plus 1. That's it, you're done. Here we're still pretty far from done. We have found the two numbers, but we don't just get to put them in this thing and be finished. We have a couple more steps to do. What we're going to do is we're going to take this equation and we're going to rewrite it with our 2x squared on the front and our 3 on the back end. But the middle term, this b, I'm going to split it into these two pieces. So instead of writing 7x, I'm going to write 6x and 1x. I think I don't need this anymore. I probably don't need this anymore either. 7x became the sum of these two things. This stays the same and that stays the same. The reason that we're doing this is now we have 4 terms. And we know what to do with polynomials that have 4 terms. We're going to chunk them. So we're going to split this right down the middle. 2x squared plus 6x should be 2x times x plus 3. X plus 3 is going to be 1 times x plus 3. I have the x plus 3's. I can move that to the front here. Bam, factored. That is how we do these things that have non-trivial leading coefficients. So we're at 15 minutes. I got time for one more of those. There we go. These are, with a lot of the examples I've done in this video, I've just sort of been able to make them up on the fly. These are a little bit more difficult to make out. If you pick a bunch of random numbers, it might not work out that well. So I'm trying to be very careful to pick the correct numbers here. And there's gotta do some work in my head to get there. So this is one where we have to use the AC method. A times C should give us, that's a big number, 60 plus 24, 84, negative 84. AC is negative 84, B is 5. So I need two numbers that are going to multiply to give me negative 84 and add to give me positive 5. And I don't know what they are off the top of my head. 84, let's see, that's 4 times 21, but that won't give me a 5. Is that 12 times something? 12 times 7? I think 12 and 7 works, right? $84 is 12 times negative 7. 5 is 12 plus negative 7. So sometimes you end up with big numbers here. Think about them in terms of what factors they have. My battery's about to die. I gotta speed through this. So we split the 5 into the 3x squared stays the same. This is going to be a 12x. It'll be a minus 7x. So the 5x became these two pieces all at once. And the negative 28 stays there. Now I can split this in half. This will be a 3x, x plus 4. Pulling the negative 7 out of here, and I get an x plus 4. That matches. So I can pull the x plus 4. If I can spell x plus 4 is the matching piece that comes out in front. 3x minus 7 is what's left, and this is the factored form of 3x squared plus 5x minus 28. I'm going to cut this video off before my computer just dies. Try the homework. Let me know what you think.